In this short video, I'm going to describe how to create a dynamic rig in Maya using a hair as an IK spline tool. So any type of skeletal system, if I just create something quick here, can be driven by forward kinematics or inverse kinematics. So forward kinematics just means if you rotate the upper level object in the hierarchy, the children will follow. So maybe it's easier to see if I go this. So imagine that's a shoulder. This is an elbow. This is the wrist. If I rotate the shoulder, the elbow and wrist will follow. If I rotate the elbow, the wrist will follow, but not the shoulder. So inverse kinematics works to reverse that order of operations here. So if I go to skeleton, create IK handle, and just click on the shoulder and the wrist, now if I look in the outliner, I've got the joint system here, joint 1, 2, 3, and I also have an end effector, so that's where the IK handle attaches, and then I have the IK handle itself, and if I select that, it's located at the wrist, which is the grandchild of the shoulder. If I move that IK handle, you can see that it's forcing the elbow and shoulder to solve their own rotation. So it's reversing the order of importance, so now the child can move and its parents have to follow along. So this can be used for things like if you wanted somebody to do push-ups or push away from something, you can use it to do that. Now if you lock down this IK handle, I don't know if this will work actually, but yeah, and then you can, so I just keyframed it into position. Then if you move the shoulder, so you can imagine somebody doing push-ups. So it's when you want the pivot point to be on the hand. So now instead of pivoting around the shoulder, we want the joint system to be locked on the floor here where the hand is, and we can do push-ups that way. So it's really useful for lots of things. That's what IK rigging is. It's reversing the order of the hierarchy that is described by the joint system. So let's just get rid of that stuff. And now if we just create a basic joint system. So I'll just do 1, 2, 3, 4, 5 joints, let's say. I'll do one more, 6 joints. You can use another type of IK system called a Spline Ik. So that is also created here under skeleton, create Spline Ik handle, and I'm going to open up the options for this. Right now, if it's set to auto create a curve. So what Spline Ik does is it controls the rotation of the joints in a system of joints here by the shape of a curve, a spline. So I can select the beginning, the end, and it creates some new stuff for us. If we open up the outliner again, I can find it. There we go. So now we've got the joint system, just like before. We've got the end effector, we've got the IK handle, but moving the IK handle now doesn't do anything, can't move it. Instead, we have to select the curve and select its control vertices, and I have to turn off just temporarily turn off my joint selection. Okay, so, it's hidden, that's why. So turn off my joint selection here, so I can select the curve, go to control vertex. Then when I grab these vertices here, you can move the skeleton around. So that's great. Now, if you wanted to animate this, typically what you would do is, instead of animating the position of these control vertices on the curve, you would turn these into what are called clusters. The reason for this is that if you want to animate the position of these control vertices don't have a transform node, so you can see over here in the channel box to the right, there's no indication of translate X, Y, and Z, scale, rotate, anything like that. So you can't really record their position in space. I mean, it is recorded, but it's not something you can keyframe easily. So instead, what you typically do is select these, each one of these separately, and then go under Deformer, and then create a cluster. So a cluster is a deformer where you can select any number of vertices or control vertices and make a cluster out of them, and it's useful for deforming things like a face model or something. But it's also a useful way to put a transform node on just a single thing, like a single component, like a vertex. So I'm just going to create that. And so you can see there's a little C there now. So I can select that. I just want to select it on its own. So it's cluster one handle. Now I've got all the translate and rotate and scale. So now I can move this around. And it's like moving the vertex around, but I can now record the changes here to translate X and Y. So this is useful for animating things like a spinal column, a tail, anything like that. But what we are going to do is something a little bit different. We're going to modify this, so instead of keyframing the position of these control vertices, we're going to use a dynamic hair to move around the joint system. So let's just delete all these things. Actually, I'll just recreate this just so we have a nice clean model. Oh, my joint selection is turned off. So again, I'm just going to create a simple joint system. I'm not bothering to name things right now, just to go more quickly. And now I will, instead of having Maya create a curve for me, I'm going to create a curve myself. So a quick way to do this is just to go to Create Curve Tools. I'll use an EP curve and click on X, and that'll make a 4CV curve. Now if I wanted to, I could rebuild that to have some more points, so it has 1, 2, 3, 4, 5 or 6 points. So maybe I will do that. So curves, rebuild. So the number of spans, let's say 6 instead, still uniform, still cubic, that's fine. Now I'm going to delete its history, freeze its transformations, and I'm going to give this one a name. So I'll just call this Orig Curve. Now with that selected in the hotbox, I can go to to N hair, and I don't want to create a hair, but instead I want to go to Make Selected Curves Dynamic. And in this case, I just want NURBS curves. I don't need to attach it to anything. So I'll make curves dynamic, and you'll see here in the outliner a bunch of new things are created. First of all, it creates a hair system shape, and that contains all the dynamic attributes of this hair. We've got a nucleus node because this is N hair, so nucleus describes the qualities of the universe in which it lives. We've got follicles, in this case just one follicle, because every hair has to have its own follicle to hold it. And the follicle has some attributes we'll need to change. And then we have the hair system 1 output curve. So we started with the original curve, which is still around here somewhere. Yeah, it's under the follicle. But then we've got these output curves, and this one's just called curve 1. I'm going to leave its name as is for now. So if we play the animation, I'm going to give myself a little more room in the timeline and make sure I'm set to play every frame. Now, nothing might happen because this curve is straight up and down right now. So it might just sit in place, yeah. So gravity's pulling on it, but it's got nowhere to fall because it's perfectly straight up and down curve. So if we go to the hair system and open up the attribute editor through Control A, and there's a turbulence field here. Let's just turn this up so we can see that hair moving. So I'm not sure if you can see that here. If we go in a little bit closer, this green shape is the hair system node represented in space, but you can see it's moving. It seems to be locked at both ends, and in fact it is. If we go to the follicle shape node, under follicle attributes, we can see that point lock is set to both ends, and we just want it to be locked at the base, so the tip will be free. So now I can rewind, and now we can see it's moving all over the place. I need some more room in my timeline. So now we have a nice dynamic curve. I'm going to turn off gravity just so we can just see like it's floating in water. So in the nucleus node, we can turn off gravity here. There are other ways to tell it to ignore gravity, but this is the easiest global way to do it. So now we just have the motion of the curve, but gravity is not going to tug it down. So play the animation a bit with turbulence on, so the output curve moves out of the middle part of the joint system, so it's easy to select. Because now we're going to go back and do the same thing that we did moments ago. Create IK Spline Handle tool, open up the options this time, and make sure Auto Create Curve is turned off. Everything else can be left alone. So now we want to select the top level joint, the bottom level joint, and then select this curve. And you'll see that immediately the joint system jumps to it because it's using that curve as its IK spline. So the thing to remember here is you have to make sure you're selecting the right curve. You can't do it to the original curve. You have to do it to the output curve. You can see it's moved it out of that group now. This is a mistake that's often made, that somebody will first make the IK handle and then the IK spline handle with the original curve and then try and make the curve dynamic. But there's a secondary output curve that's created and it won't affect the IK spline. You have to do it in this order. So now we can see it at work here. My computer's a little old, it's struggling to solve all this stuff. So now, of course, you can use this for rigging. So if you had separate models, let's say like beads on a string sort of thing, I can create just a polygon sphere. Just going to shrink it down a little bit, duplicate it, move that one up a bit, duplicate that again. So I could just parent these spheres to these joints. So I'm just middle mouse dragging one node onto another, and it makes a parent-child relationship between them. Oops. Selected the wrong one there. And now when I play the animation, hopefully it doesn't crash the computer, but you can see that now the spheres will just follow along. So if you need to animate something like this that has to move in a natural sort of fashion, you can easily do that simply by parenting. Now, if you have a piece of geometry, let's say like a microvillus, something like that, that you want to have moved, then you'll have to skin that geometry. So I'll just create a simple cylinder. Let's scale it up a little bit more. it needs some divisions along its long axis, so along its height. Let's give it 20 divisions. It's going to go into 4 mode here so I can see. So if I select the joint system, shift select the piece of geometry, I should really delete its history actually first to avoid any Maya strangeness. So if we select the joint system and then the piece of geometry and go to skin, bind skin, you can open up the options, but we can just leave it at the default settings for now. Bind the skin, and now if we play the animation, you get a nice natural animation of this thing deforming. So if we just hide those. And so with any sort of dynamic system, you're giving up some control for the convenience and sort of natural motion that can be achieved. So if I need to alter the type of movement that's happening here, I can go in and change the turbulence settings, change the frequency or the speed, turn down the intensity, whatever. Let's just hide this. So it's got greater speed, more frequency. Now, sometimes you'll see this happening on screen, and I think this is just the on-screen representation not being able to keep up with the the solution of the dynamic, because you'll see it pops back in sometimes, so it's not something really to worry about, because at render time it's going to solve each one at a time, each frame at a time. So those are the basics about how to use a curve as a dynamic object that can drive an IK spline, which in turn can drive the animation of a joint system, which itself can drive the animation of separate pieces of geometry or one skinned piece of geometry. So I hope that's helpful. It comes in handy in lots of situations. There are other things to consider, like N caching. So if you're rendering on multiple machines, or if you want a predictable result, you want to cache the results of the hair system. But that's something we can talk about at another time. Thanks.